In this video we're going to have a look at hexadecimal color codes that can be used in Python for setting things like the background color of tkinter widgets. As we have seen in the previous two videos, we can create an instance of a canvas using this line of code here. And I want to reference this named argument here, which is background is assigned red. That will mean that we will have at runtime a window that will look like this. The window will contain the canvas, and the canvas is red because of this setting of a named argument. If we consider the named argument, you can see we're assigning it red. Now, of course, I could choose other values to go here. I could put blue, I could put green, and there's a variety of other names that can give us a specific color from what's available within Python. What I'd like to point out here is have a look at this. You can see it is a string. Now, it is possible for me to do this in another way. If we look at the following program, what you can see is in this position, I've removed the red and I've put another string. Now, this other string, if you look, has this symbol and it has FF0000. Now, let's have a look what this will give us. And you can see it too gives us a canvas that's got a red background. So this is another way of making the background of the canvas that's created on this line red. Now this is an example of a hexadecimal color code. And the question we need to ask is, why has this made the canvas red? How does this hexadecimal color code represent red? Well, let's have a look at some of the features of this to begin with. We can see we have this symbol. We can see we have FF here, then 00, then 00. Now, FF in this position means let's have the maximum amount of red that's available. Here, well, that means we're going to have no value of green, and this here means we're going to have no value of blue. And consequently, what this will give us is red. And while we're here, have a look at this, and you can see that it is in quotes. This too is a string, in the same way in the previous program we had red being a string. So here's the same program again, and if you look here you can see I'm using the hexadecimal color code, and if we look at the runtime for this is what we would expect. It's what we've already seen. We can see the canvas with the red background, but let's compare this program with this one here, and what you can see is this is now the color code, the hexadecimal color code, and in this position I have 99. Now that is a smaller hexadecimal number than this FF, which means that I do have a certain degree of red defined here, but not the maximum amount of red. And here I have no green and I have no blue. Now what that will give us as the colour of the canvas can be seen here. And you can see that it's still red, but it is not as bright a red as the one above. Now this one here is brighter because this FF is a bigger number than this 99, where the 99 gives us a certain degree of red, hence we get this duller looking red here. Let's now consider this program, which is identical to all of the programs we've seen so far in this video, except I've now changed this hexadecimal color code. And you can see I have 00 here, which means no red. I have FF here, which means the maximum amount of green, and I have no blue. So if we have a look at what this will look like, it'll look, as you can see here, green fully on. Let's now have a look at another program where I've changed the hexadecimal color code again, and here you can see we have no red, we have no green, but we have FF, which represents the maximum amount of blue, and we can see what we get is a canvas that is the color blue. Looking at another example, here you can see that the hexadecimal code is FF in the red position, FF in the green position, and this 00 means we have no blue. Now what this color code is going to be doing, it's going to be mixing together the red and the green, red, the full amount of red, and the full amount of green. And what you need to realize is you're mixing light here. Now when you have this color code, what you're going to see is a canvas that is yellow, with its background color set to yellow by this hexadecimal color code. So mixing red and green gives us yellow. If we carry on and have a look at this one here, we have a hexadecimal number here representing the amount of red. We have another hexadecimal number here representing the amount of green, and we have another hexadecimal number here representing the amount of blue. And this number will give us the following colour. It'll give us a specific shade of orange. Let's consider the components of the hexadecimal colour code in turn. These two hexadecimal figures, they represent the amount of red that's in the final colour. Now, we can see in our number system that in this position we have the value of 0 being possible through to 255. Now, in reality, what we have in this position is a binary pattern, an 8-bit binary pattern. And with an 8-bit binary pattern, you can have the range of numbers being from 0 to 255. But of course, binary is notoriously difficult to remember. That's why we use hexadecimal. It's easy to convert from binary to hexadecimal and vice versa. So when we see FF here, that really is 8 ones in a binary byte. Every position of a binary byte is set to a 1, but we use FF instead. Now, if you wish to know more about hexadecimal and binary, which I recommend if you don't understand it, is seek out on this channel the playlist on number systems, where I show what hexadecimal and binary is and how to convert between them. But what we can say that we have in this position is from 00, where 00 is the hexadecimal number, to FF, where it is also a hexadecimal number and is the biggest number for the range that can go in this component position here of the overall hexadecimal colour code. What we can go on to say is we have 256 levels that are possible for the colour red, from 00 to FF, or if you like, from 0 to 255 in our number system. Consequently, if you go from 0 to 255, there are 256 possible levels for the colour red. If we now consider the green component for the hexadecimal colour code, we can see that it here is shown as FF, so that's the maximum amount of green I'm showing here. But again, what we have here in our number system is from 0 to 255. But of course, we're dealing with the hexadecimal colour code, so it goes from 00 to FF. If we carry on, we can also see that the blue component is shown here, and again that can be from 00 to FF, and like the red, the green and the blue, there are 256 levels possible for the blue component of the overall colour created by the hexadecimal colour code. Let's therefore consider the colour code that we've looked at in the last 3 slides. And you can see we have FF for the red component, FF for the green component, and FF for the blue component. Now this will mix the maximum colour of red that's available with the maximum colour of green with the maximum colour of blue. Now, what colour is this going to give us? Well, let's write a computer program, which is the one we've been looking at in this video. And here you can see that I've put the hexadecimal colour code as a string, because note these 2 quotes here. And what do you think this will give? Well, what's happening is we're switching the red fully on, we're switching the green fully on, and we're switching the blue fully on. Now, when you have all of the light there, what you're going to get is white. You can see that having red, green and blue on fully gives you the canvas colour of white. Now here's another hexadecimal colour code, and you should see that everything's 0. This is the red component, meaning we have no colour of red. This is the green component, we have no colour of green. And this is the blue component, we have no colour of blue. So if I put this colour code into the program we've been using here, and you can see I've set it up as a string again, what colour do you think this is going to give? Well, it is giving no red, no green, no blue, which means there's no colour. So what we're going to get, as you can see here, is black. So really what this colour code is saying, what this hexadecimal colour code is saying, is we have no red, green or blue, we have no light, and of course if you have no light you end up with black. Now let's consider this color code, which we've already seen in one of the programs shown in this video. Here we have this hexadecimal number representing red, this hexadecimal number representing green, and this hexadecimal number representing blue. And when the amounts of red, green and blue are mixed together as represented by these numbers, what we will get is this colour here, which is the shade of orange we've already considered. Let's take a closer look at this colour code, and you can see I've made this red, green and blue to highlight what component colour they represent. If we look at ED, that's a hexadecimal number. Now, if I wanted to look at what that was in our number system, because when I see ED, I'm not really sure what value it represents in the range 0 to 255. So I'm going to convert it to the denary number system, and it is 237. Now, as the maximum number is 255, this is quite a lot of red that we have with this hexadecimal code we're considering at the moment. This 91, well, straight away I must stress that that is not 91, that's 91 in hexadecimal. If I wanted to know what this was in denary, I'd have to convert it to denary. In other words, convert it to the number system we're all used to. And when we convert it, we will see we'll get 145. Now, that's a reasonable amount of green. If the maximum amount of green is 255, that's over halfway to the maximum value of green that we can get. If I have a look at this isn't 21. If I convert that to denary, what we're going to get is the value of 33. So that's a certain amount of blue, but clearly it's not a very high value, because the biggest amount of blue we can get, as represented by these numbers, is 255. But what we will get here from this colour code is the colour orange we've already considered. And if you think about it, when you had red and green at their maximum, you got yellow. Here we've got quite a bit of red, a reasonable amount of green, and we've got a little bit of blue. And orange is kind of closest to yellow on the colour wheel, so we end up with this orange colour. Now, of course, you can have lots of different values for these codes, and it's almost impossible to remember which colour code gives you what colour. So you can go on the web and look up charts, and they'll give you all of the numbers for particular ranges of colour that you want. And of course, you can simply forget about using colour codes. You can use red, green and blue, and there are other names for a variety of colours that you could have. How many colours are possible if we decide to use the hexadecimal colour code to set things like the background colour of a canvas, the colour of a window, the colour of a line that we may wish to draw, and so on? Well, let's consider what we have. We have red, green and blue. If we consider the red, green and blue, they will be numbers in the program, and the numbers will go from 0 to 255 in each case. And of course, if we consider that in hexadecimal, they go from 00 to FF in each case. So what we can say is we have 256 levels in each case. So there are 256 possible values of red, 256 possible values of green, likewise 256 possible levels of blue. So we could have 1 for red, 1 for green, and 255 for blue, and that will give us a particular colour. Now, how many different combinations are there for all of these different possible colours of red, green and blue? Well, what you do, you take how many levels there are, multiply them together, and you get 16,777,216 possible colours. Now, that's a lot of colours. Now, the thing to bear in mind, this is theoretically the amount. It then depends upon the quality of your monitor and of the setup within software that will dictate how many of these many different colours you can actually view within your computer program. Before I end this video, what I'd like to do is just to remind you of the 3 number systems that it's important that you have an understanding of if you're really going to get into coding in any language. And what you can see here, I have a column for denary, 1 for binary, and 1 for hexadecimal. Now, when we have a 0 here, and I want to represent that with 8 bits, a byte in binary, this is what we get. Now, 1 byte in hexadecimal is 00. If I look at 1, this is the value of one in an 8-bit binary number, and this is it in hexadecimal. If I come down here to 10 in our number system, the denary number system, this is what it looks like in binary, and this is what it looks like in hexadecimal, 0A. Now, I'm showing the first 11 numbers here, starting from 0 and going up to 10. Obviously, there's 256 possible binary pattern combinations. I can't show them all on one slide, so what I'm going to do, I'm going to go to the end of that range, and here you can see I've gone to 255, which is the top end of the value of red, green and blue we can have, and that's represented in binary by all ones, 8 of them, and that's FF in hexadecimal. If I look at 254, that's what 254 looks like in binary, and that's what it looks like in hexadecimal. So what you can see here are the hexadecimal values for these denary numbers, and the reason we use hexadecimal is because we have to really realize that everything in a computer program ultimately becomes binary, but these patterns are difficult to remember, but it's easy to convert the binary numbers to hexadecimal. That's why we always go with hexadecimal. And as I've already said, in another playlist on this channel, I show how to convert between binary and hexadecimal and vice versa. So just take my word for it that we can easily get from binary to hexadecimal and vice versa. That's why we have hexadecimal color codes, because their color are really set up in binary patterns. It's a binary pattern that sets up the colors within the computer program, but as humans we represent these binary patterns with hexadecimal codes. Because the hexadecimal codes are easier to remember when compared to remembering the binary codes, and we've already said it's then easy to convert between binary and hexadecimal and vice versa. So if I wish to use a hexadecimal color code, what I have to remember is if I'm going to assign it to the background named argument when I create the canvas, I need these two quotes here, I need this symbol, and I need the red, green and blue component. And this we've already seen gives us a shade of orange. But what you're looking at is a hexadecimal color code, which really should be binary because that's what it ends up looking like in the code. This is 8 bits, this is 8 bits, and this is 8 bits. But what we have is this is the hexadecimal representation of 8 bits. This is, again, a hexadecimal representation of 8 bits, i.e. a byte. And this is the hexadecimal representation of the byte. Red, green, blue. Now, if I wanted to generate a random color, which is what I'm going to do in the next video, then what I really want to do is to generate these characters here. I would need to generate this randomly, this randomly, this randomly, and so on. So I could end up here with a randomly generated hexadecimal number, which would mean that I would end up with a randomly generated color that can be used in a computer program. So the next video is going to look at how we can randomly generate a color, which means we can see how we can randomly generate this hexadecimal color code, because that will obviously then give us the random color, because the hexadecimal color codes give us different colors if the codes themselves are obviously different. Check out the supporting website for these videos. In addition, why not follow me on Twitter, as I issue a tweet every time I upload a new video.